Cool, I'm gonna keep my phone away. You all have my time, okay? I'm here for you all, so I'm so much happy. It feels so bright and flashy, right? I was here yesterday, and I just couldn't bear it. So I made a job simple for you. Uh, Tried my best. Couldn't work with the illustration there, but hats off to my design team. They were like very quick on that. But hey everyone, thanks for being here. Myself, Siddharth Dayalwal. I am a developer community specialist. I'm working at Storyblock, which is a headless CMS. If you want to know more about it, we can do that separately, but this talk is something different. To add more details about myself, I'm traveling all the way from India. This is my first time here in Romania. It's amazing to be here, first of all. Yes, how many of you are first time here? Quick raise of hands. Quite some of you. So we need to talk about how was your experience so far. But apart from my day job, out of my profession, I also run a hacker community based in India called Hack This Fall, which is one of India's most thriving hacker communities. I've been running that. We just did a milestone edition last year, so it went great. And I'm very happy when I meet conference organizers, community organizers, and leaders. And I have talked to a bunch of you already here, so I'm very excited to share some of that experience as well. I've been running, growing, managing communities for over 5 years now. Also, the dev programs alongside it is just something that makes me excited. I love traveling, trying out new food, knowing more about the culture, history, and so much more. And I have 1 cat and 2 dogs, and they are adorable. So, yes, this is my first time here at JSHeroes, and I'm very, very hyped to be here. I've been listening to all the talks, and it's just amazing. Love the level of bar that it has brought to the community member, and you all made it happen. So, round of applause for each and every one of you in this room here. Okay. Well, I'm not a veteran. I do have my speaker notes. I might just keep on checking that. But today I want to talk about something that has been hiding in plain sight. Of course, you see the cognitive load crisis, that term here. And honestly, we spend so much time in designing and like scaling systems. But at the same time, what are we doing? We are like scaling it horizontally, vertically, auto-scaling it. But we almost never talk about the humans who build those systems, who design those systems, right? And I'm not going to talk about in this presentation of mine more about the productivity hacks. It's not about the latest tooling that comes to the market, especially with AI and so much more beyond, but it's about how the very system that we build or are designing is like quietly burning out the people who are meant to be taken care of. So without further ado, let's quickly jump onto it. And I do have like a couple of comparisons, some strong points that I'm going to share through my slides, so keep a check on that. Now, here's the paradox that we are living in. If you see on the left, there's the promise that we make that we have more powerful tools than ever, right? Better frameworks, smarter CI/CD, AI assisting coding. Like the developers of our generation has like everything that they really need, something that can like make them more resourceful, more automation. I mean, it's the best time. But this pitch essentially is that all of this development that is coming along the lines of new trends is supposed to make our life easy, and it should be getting more easier day by day. But if we just look at on the right side, the reality is something different. Now, go and talk to any of your team lead, any of the senior engineers, and like really talk to them about this situation, and I'm sure they'll tell you something quite opposite to what we see on the left. And honestly, teams are drowning. There's just so much of bad code, but it's still not the real reason. It lies in the complexity that comes along with it. Fragmented tool chains, constant context switching, decision fatigue, rising burnouts. The rate of it is like immense. So if we just talk about all of this together, something isn't just adding up, right? And I think the problem isn't about tools themselves. It is how we are designing system around those tools. So we're going to talk about that in detail. And to understand why this is happening, we definitely need a framework that can help us or allow us to, just understand the reasoning, what is happening, why is happening, right? Cognitive load theory comes from an educational psychology, and it actually maps perfectly what we do on a day-to-day basis. And there are three types, essentially, starting with intrinsic, which is very basic, and it's the real work. So it's basically the complexity of the problem that we are trying to solve. Writing business logic, modeling a domain, solving a real puzzle out there. And essentially, you can't eliminate this, and you shouldn't think in that direction, because at the end of the day, we turned out developer for a reason, right? And this is actual reason why we are who we are. Next up is extraneous load, and this is everything that environment piles on top of it. So you name it, like bad tooling, unclear documentation, confusing configuration, poor developer experience, and this is a pure waste in a way. So it doesn't help you solve the problem, it just makes it super hard. Now, the third and final one is germane load, which is the effort of learning and building something along to what we get as like new things around in the market. But it only works when it's intentional and when it's like genuinely helping you. It goes in the wrong direction, it goes in the harmful state when it's something that really doesn't matter and something else is more important for you to grab attention on. So here's the key inside most system complexity we deal with on our day-to-day basis within the modern JavaScript frameworks is the center one, which is extraneous cognitive load. And it's not the problem being hard, it's also the environment that kind of builds around the tooling that we have gathered in this ecosystem. So the complexity is designed in, but let me remind you that it is not inevitable. And let's talk more about that as well. I wanted to paint a picture in front of you with some figures that I have been able to gather while I was preparing for this talk, right? To start with, 12 plus tools touched daily, like your IDE, terminal, browser, Slack, Jira, GitHub, CLI dashboard, monitoring tools, documentation, Figma, maybe some other database client out there, right? Each one of them has its own mental model that it brings along with it, its own keyboard shortcuts, its own notification system. Secondly, 23 context switches per hour. Now that's roughly one context switch every 2.5 minutes, which is insane. Know that every context switch costs you something. I was going through this online, and there was this research that I was able to find from Gloria Mark, who is an American psychologist at the University of California. And she mentioned that it takes up to 23 minutes to get back into deep focus after an interruption. But with the numbers, we are getting interrupted 23 times within an hour, which is, insane. You can definitely do the math. It's simple. Next up is 40% of our time goes on the non-coding tasks, which means configuring, debugging pipelines, reviewing alerts, updating the tickets with the progress and status. Sitting in stand-ups, talking about the work we are doing while we are supposed to actually do the work. All of these kind of adds up to it. And the last is 300 plus notifications on a daily basis. You know the tools. You have been there, Slack, email, GitHub, CLI monitoring. All of this are screaming with notification and require your attention simultaneously, all at once. And here's what I really need you to hear. These aren't personal failures. We think about that, we have failed, but no, these aren't bad habits. These are system design outcomes in a way. So the architecture of your workday proceeds or produces this fragmentation. So it's not your failure, and you shouldn't think about it. But if we just talk about, and I wanted to map this into like broader 5 categories. We've talked about in the previous slide on extraneous cognitive load, and all of these 5 major points actually shows how it shows up nearly in every modern JavaScript teams out there. To start with, first is tool chain fragmentation. So we don't just use one tool, right? We use like a group of it, like a constellation that we are part of. So with each of its like tool, it brings along with it like its own content model, configuration format, and release cycles. Now, of course, every new tool is like a new thing to learn, new thing to adapt, debug when it breaks, and it does take a lot of time. Second is configuration overload. I mean, the JavaScript ecosystem loves configuration, isn't it? Webpack, Babel, ESLint, TypeScript, Prettier, your CI pipeline, there's just so much more. And each configuration kind of, or the decision tied to each configuration multiplies the complexity or multiplies every one of it with the coming or the subsequent one as well. So it kind of build on top of each other. The third one is the workflow discontinuity. Now our workflows is inherently fragmented. If you see, we are jumping between code, PR, deployment, monitoring, alert, fix, and then we kind of keep on repeating things, right? There's no single cohesive flow that we are trying to actually follow within this process of us doing something meaningful. And every transition that we are part of is a cognitive handoff all at once. Fourth, decision fatigue. Now, should we use Redux or Zustand? Should we go with components or clients? Are we using this library or that library? Is it like monorepo or a polyrepo? If you see, every choice consumes some resources around the cognitive crisis. And even if you make the right one, you're still giving that resource energy out there, and you're using that time, which can be used for something even more productive. Last but not the least is alert and information overload. And believe me when I say this, we are drowning in signals. I've said it, monitoring, logging, Slack, there's just so much more. CI, everything demands your attention at this point while you're trying to make things more valuable. And it all happens so simultaneously that you are too occupied all the time. And we are all humans. Our brains aren't meant for that. It's not meant to work in a way that system asks us to work in. So quick note on all of these pointers that I've already added here. None of these are the actual problem that we are trying to solve. They are just part of the extraneous cognitive load that I was talking about earlier. Now, this is what I call the tool paradox, right? Now, each individual tool that you are trying to use, it solves a problem. I agree. ESLint catches bugs, Prettier formats code, your TypeScript adds type safety, CI/CD automates deployment, monitoring catches production issues. I mean, they are doing the job they are meant for, and we are making the most of it. Totally agree. And also, in the process of like adopting any of these tools, no one is wrong. I repeat, we are just trying to make our life easier, right? But is it really? Look at this chart. Cognitive overhead doesn't just grow in a linear way. With the number of tools, in like increasing number of tools, it also grows non-linearly. So with 2 to 3 tools, you might have like a manageable complexity. But when the number of tools goes beyond 12, 20, or even more, you have an ecosystem of interactive configurations, competing abstractions, and all in all, the cascading upgrade dependencies. So this is where you start thinking that, are we in the right direction? Well, this is the real trap. And we just keep on adding this stack instead of thinking to subtract any. And at this point during my presentation, I would just like to take a moment and give this open-ended question to you all. And I really want you to think about it, that when was the last time your team thought of removing a tool? Take a pause, think about it, and then you'll start finding some answers. But with all of this coming in, of course, there are problems, right? If tools create complexity, surely automation can be the solution to it. Isn't that the right answer? But we can just like automate things and take the pain away. But is that for real? So I wanted to talk about why that's often a myth and why adding more automation can also add to it, like without thinking of better design systems and how it can make actually things more complex for you and your teams, or make it even more worse. But before jumping onto that, I just want to highlight that not all automations are created equally. They have their ways of delivering the result that they are meant for. If you see on the left, automation that actually reduces load, eliminates repetitive decisions, works silently in the background, it has sensible defaults, it fails predictably, and at the same time, it lets you know, there's a clear way for you to recognize how it has failed. It reduces options and not increase them at the same time. But if you see, on the contrary, on the right side, automation that also amplifies the load that we're talking about here. So it requires constant configuration, generates noise, and false alerts. It kind of introduces new abstractions that needs to be learned and taught to individuals. It fails silently or cryptically, which is, again, something bad. And it creates new decision points that weren't there before or weren't existing before. So think about your own CI pipeline right now. Is it invisible, or is it something that you fight with every week? I mean, think about your linting setup. Does it silently enforce standards, or does it generate a constant stream of warnings that I believe some of us have already started to ignore on a daily basis, right? So the question here isn't about should we automate. That's definitely not the question. That ship has already been sailed. The actual question that we as developers should really ask each other, ourselves, our team, is, does this automation reduce decisions or create new ones? Again, think about it. I'm going to throw some open-ended questions. And AI, I had to add it to my slides. It's inevitable to not add AI. It's the latest addition to this landscape, to this picture that I'm trying to frame in front of you all. And I believe it deserves an honest explanation. Now, AI tool does promises to reduce cognitive load within teams, and in some cases, they genuinely do. I do agree. But if you see, poorly integrated AI introduces 3 new burdens, which I've tried to list in this slide as well. To start with, verification overload. Now, every AI suggestion that comes to you still needs to be reviewed, still needs to be verified through or understood and validated by you as an individual. At the same time, for complex code, the cognitive cost of verifying those correctness of that particular code can be higher than writing it yourself. So you have to really understand that you're not eliminating the work. You're just trading the writing of something with completely reviewing it. So that's the trade-off that you're trying to do. And while we think it is making it easy, it's really not. Second is context mismatch. I think Craig already mentioned in his talk yesterday about how it needs more context, how AI needs more context. And it doesn't know your specific case or your team's convention or your architecture's pattern, really. It will give you some generic output. And then adapting that generic output to your context is something that is on you. And that's real cognitive work that, unfortunately, not a lot of people talk about. And last but not the least is skill atrophy risk. If you outsource routine, day-to-day discussions to AI, think about it. The decisions that can deepen your understanding towards a particular thing, you're just starting to lose that intuition of making those decisions. And these are the decisions which you will really need when things go wrong, when things break. And believe me, it will break. What are you going to do during this time? Not all the time we'll have AI to talk about. In this process of depending ourselves on it, we are just losing that all in all. So AI should be reducing the cognitive load. Yes, I agree. But we need to be very, very intentional with the kind of approach that we want to accept and about how we integrate it, and not just bolt it on our day-to-day tasks and routines. So, yes. Now we are moving from the problem to the solution, because of course I talked about the problem a bit, and you will expect some solutions coming from my way. When we talk about the problem, it was tools, automation, AI, how that develops, how that kind of adds to the cognitive load. They all amplify it in some or the other way, right? But only when it's poorly designed. So now let's talk about what actually works. What does it look like when the design system that work with the human cognition instead of like against it? And in my next slides, this is the time when you should start taking notes, because this is like the game changer. If you have phones, you can of course capture them. I would like to like summarize as much as possible. So pay attention. And I'll start breaking it down into simple principles. To start with, first principle, reduce decisions, not options. Now, every unnecessary decision a developer has to make drains cognitive energy from the decisions that actually matter. So this is the intrinsic complexity of the problem, which we really need to understand. And there are three practical patterns around it. First is opinionated defaults. You might feel offended, but stop debating tabs versus spaces, semicolons, importing order, all of these things. Pick something which is truly sensible for your team, for your use case, and lock it in and just move on. Convention over configuration isn't something like lazy, but it's cognitive kindness. And I just love the way this comes through the meaning of it, because every convention is kind of a decision your team never has to make again, like going further while you're working on different topics. Next is golden paths. So define what the normal workflow should look like. If there's a standard way to do something, to create a new service, to deploy a feature, add a dependency, make that path an obvious path and the easy path. So you should make the right way the default way and make the wrong way the hard way. You should really start defining that. Last is decision records. Now, write down why you made a key architectural decision, ADRs, architecture decision records. This prevents the same decision resurfacing every quarter with your new team members. So this way you can just decide one, document it, and proceed to the next part. Principle 2, simplify workflows, not just tools. And if you see the before and after here, in the before, a developer touches 9 separate contexts between writing a code and seeing it live. It's code, lint, test, build, PR, review, merge, deploy, monitor. And I mean, with each transition is a cognitive handoff, a moment where you lose context and also have to rebuild it once in a while. But in the after one, which you see just below that, we've consolidated that into 4 steps. And it's simple. Write code, push, automated pipeline in between all of these, and it's live. So isn't it very simpler? So we're having same outcome in this case, but a fraction of the cognitive cost that we are trying to bring. The 3 patterns that we talked about earlier also applies here. So we consolidated tools, fewer tools doing more is better than more tools doing less. Automated the handoffs. Every manual step added in between is in between the code written and when the code goes live is a cognitive tax altogether. And create a single pane of glass, like one dashboard, one simple status page, and one source of truth for everything that you're working around. And stop making developers like mentally aggregated between different multiple systems altogether. Third principle, design for flow states. Now, the stat that I mentioned earlier, it's kind of worth bringing it back. It takes 23 minutes to regain deep focus once you are interrupted. And I would hate to do that. I mean, we just have 24 hours. There's so much to do. We are so ambitious with so many things. But understand this, if your system design has this constant interruptions while you're working, you are systematically just preventing your team to kind of regain or reach that ever-flowing state of focus. So I've again kind of distributed these patterns into a couple of things, like how you can protect your focus. And it's not too hard. It's very simple and straightforward, honestly. First is batch notification. Stop the real-time ping for each and everything. Your CLI result, your PR comment, you can just group them by priority, deliver informational stuff in a way of digest, just avoid it making live or in real time. Next is async first communication. Make this a default, like you do not need a Slack thread for everything. You do not need a meeting to talk about every detail that you're going through. Reserve synchronous time only for real-time discussion that really are important and worth bringing it with a group of people. Third, context-rich error messages. Now, when something breaks, give developers, give yourself, your team, other people, everything that they need in just one place. What happened? Why did it happen? What are the things that they should be aware of? What to do next? So give it all. Don't make them go digging with stuff that they really deserve to know at very first place. And the last point is protected focus time, which is very underrated but is equally important. Build uninterrupted blocks into your and your team's calendars, and essentially make them a cultural norm. I mean, it should be just very common, not something people have to fight for or feel guilty about when they are asking for it. Final principle, principle fourth, and this is very relevant in times like these in 2026 with the AI emerging. Use AI to absorb complexity and not add it. And let's be very specific about what it means. And this is a very clear comparison which I can go through one by one. Bad AI generates code you don't understand, whereas good AI explains every existing code and also suggests context-aware changes. Bad AI automates decisions without transparency, whereas good AI surfaces options with clear trade-offs, and you as human are the ones who are making the call. Bad AI adds a new interface to learn and manage new things, whereas good AI integrates into the existing workflows, invisibly, by the way. So the bottom line here is the best AI integration is the one where developers forget that it is there, and because it just makes things or their existing workflow very smoother, not a new thing to learn, not a new tab to check, and just less friction. So here's something practical you can take away to your teams today after this talk of mine. Before you add anything new to your system, please, it can be a tool, a library, a process, an AI integration, literally anything. Run it through these 6 questions. Does this reduce the number of decisions developers make daily? Can a new team member understand that in their first week? Does this fall in a way that helps, not confuses? Are we adding this because of a real need, or it's just a fear of missing out? What are we removing to make room for this addition? Or does this protect focus time, or it's just fragmented further? So these are the questions. If you can't answer yes to most of these, my friends, you really need to think twice, right? And seriously, I've seen teams like working on it and transforming the way they have worked. So not adding new things, just filtering it out, essentially, is the key. And feel free to take a picture of this and go through these questions whenever you have a similar discussion. And I want to leave you with a simple mental model that I strongly believe on, and it kind of ties everything together. Developer burden is equal to system complexity minus the cognitive support, and there are really 2 ways to remove this burden. First, decrease system complexity, fewer tools, simpler architecture, less configuration. Just think of subtracting before you're adding. Second is increase cognitive support, better defaults, clearer paths, and smarter automations. Make the system help you think, not force you to think harder. And the best teams do both of them simultaneously, and they're constantly asking these 2 questions. Can we simplify this, and can we make things easier to think about? Final just wrapping up things, let me leave you with these 5 takeaways that would summarize everything. Burnout is a system problem, not a people problem. So stop telling developers to meditate and start fixing the systems that drain them. Developer experience is an architectural concern. It belongs in your system and design decisions, and it's not just something that we need to talk with HR. More tools does not mean better DX. How tools integrate matters far more than how many you have. And automation should reduce decisions, not create new ones. Test every automation around this principle. And finally, design for calm, sustainable development, and not just velocity, because speed that burns our team, your team, isn't speed, it's debt. So think about it. And if there's one thing I want you to take away from this slide is rethink how you design systems and teams and not just code. With that being said, thank you so much for being an amazing audience, kind listeners. And I'm around. Thank you. I'm around if you want to talk about your experience with cognitive load, any shared struggles, what worked for you, what did not. And thanks a lot, JSHeroes, and the wonderful team for having me. It's been such a pleasure. That was my time, 50 seconds above, but I'm Siddharth signing off. I'll see you around. Thank you so much.